Hello everyone, today I will present about computer organization and architecture. First, let me introduce myself. Hello, I'm Oktavian I'm here to answer a few questions and problems about computer organization and architecture. In this presentation, there will be two content. First is review questions and second is problem. In review question, there will be 9 questions that needs to answer from 1.1 until 1.9. And for a problem, there will be one problem to be solved. First, let's talk about the review question. Review question 1.1. What in general terms is the distinction between computer organization and computer architecture? Well, computer organization deals with the operation unit and how they relate to specification, while computer architecture deals with the attributes that deal with the execution of a program. Review question 1.2. What in general terms is the distinction between computer structure and computer function? The answer is computer structure deals with the way the components in the computer are interrelated, while computer function deals with the operation of the individual components as part of the structure. Review question 1.3. What are the four main functions of a computer? The answer is data processing. Data may take a wide variety of forms and the range of processing requirement is broad. However, we shall see that there are only a few fundamental methods or type of data processing. The second is data storage. Even if the computer is processing data on the fly, the computer must temporarily store at least those pieces of data that are being worked on at any given moment. Thus, there is at least a short-term data storage function. Equally important, the computer performs a long-term data storage function. Files of data are stored on the computer for subsequent retrieval and update. Third, data movement. The computer operating environment consists of devices that serve as either source or destination of data. When data are received from or delivered to a device that is directly connected to a computer, the process is known as input-output or I/O, and the device is referred to as a peripheral. When data are moved over longer distance to or from a remote device, the process is known as data communication. And the last one is control. Within the computer, a control unit manages the computer resources and orchestrates the performance of its functional part in response to instruction. Review question 1.4. List and briefly define the main structural components of a computer. First, Central Processing Unit or CPU, also known as the computer processor. It controls the operation of the computer and performs data processing. Main memory, part of the computer that stores data. The third is I/O, input and output, moving data between the computer and external environment. The last one is system interconnection, example system bus, provide for communication between the CPU, main memory, and I/O. Next, review question 1.5. List and briefly define the main structural components of a processor. The first one is control unit. Control the operation of the CPU. The second, arithmetic and logic unit or ALU, performs data processing function. The third, registers, provide for storage internal to CPU. The last one is CPU interconnections, allow for communication among control unit, ALU, and registers. Review question 1.6. What is a store program computer? A store program computer has the program stored alongside memory, so the computer can read it from memory, allowing it being altered or set. Review question 1.7. Explain Moore's law. Morse states that the number of transistors that could be put on a single chip would double each year, but in fact it was revised. One is started to double each 18 months. Or in the longest explanation, Morse states that there is a doubling of the number of transistors on a chip every year, but now about every 18 months. It is something that had continued since Moore had made his observation. The cost of the parts has also remained consistent even with the increase of density. Computers have been able to become much smaller due to this as well. The chips, for the most part, are the same size, though the number of parts on the transistor has majorly increased 1.8 least and explain the key characteristic of a computer family. Next is review question 1.8. List and explain the key characteristic of a computer family. A computer family shares the same architecture, allowing older program versions to be run in newer hardware machines. Along versions, you can see a faster processor speed, a larger memory capacity, and an increase of the number of capacitors in a processor chips. For the key characteristics of a computer family, there is first similar or identical instruction set, which is different computers in the same family could use the same or similar instruction sets. Lower-end machines may contain a subset of the instruction set of higher-end machines. This would make software move up the chain, though software written for a higher-end machine might not work on a lower-end system, because due to missing instruction. The second is similar or identical operating system. The OS may be shared by the same system of the same family, though there may be more high-end features in the OS of higher-end machines. The third one is increasing speed. As one moves through the models of the family, the higher-end the machines, the faster the speed. This means an increase in rate of instruction execution. The fourth is increasing number of I/O ports. There is an increase in the number of ports going from lower end to higher end. The fifth is increasing memory size. Size of the main memory increase growing from lower end to higher end. And the last one is increasing in cost. Cost of the computer goes up when going from lower end to higher end. Next one is the last review question is 1.9. What is the key distinguishing feature of a microprocessor? Well, the answer is they contain all the components of a CPU on a single chip. Well, now it's the second content, which is a problems. Problem 1.4. The question is, given the memory contents of the IAS computer the shown below, show the assembly language code for the program. Starting at address 08A, explain what this program does. As you can see, there is a table here which is content, address, and contents. Well, contents are divided up into two 5-byte instructions, LH and RH. In contents, there is divided by 2. Each is 5 bit. So for the LH instruction is 010FA, and for the opcode is 0101, and for the address is 0FA, and for the RH instruction is 210FB. For the opcode is 21, and for the address is 0FB. Since this is in hexadecimal form, you have to convert the number to binary form and use the IS instruction set. For the LH instruction, the opcode is in hexadecimal form. You need to change it or to convert it into binary form, which is 01 into binary is 00000001, and in binary form you must change it to IS instruction set, which is become LOAD MX. MX here refers to the memory address location 0FA. The first 5 bits of 0A should read LOAD M0FA, and for the RH instruction, the opcode here is 21, and convert it into binary, it becomes 00100001, and convert it again into IS instruction set, which is STOR MX. MX here refers to the memory address location 0FB. The second 5 bits of 0A should read STOR M0FB. Now do this for the content in 0xB and 0xC, and you will have your assembly language code, which should look like this. For the address 0xA, the content will become like this: LODM 0FA and STOR M0FB, and for 0xB, the content will become like LOAD M0FA JUMP plus M0XD, and for the address 0xC, the content will be like LOAD minus M0FA STOR M0FB. And what this program does, this program is to store the absolute value of content at memory location 0FA into location 0FB. I think just that from me for my presentation right today. Thank you very much for your attention, and thank you for watching.